Hello everybody, and welcome to your very first video for our geometry class. I'm so excited to work with you. Please make sure that you are taking notes as we go. You want to make sure you're getting all the definitions down and any extra helpful tips that I might tell you today. So today we're going to be working with the introduction to geometry. We have to go back to the basics to make sure we understand everything before we actually start getting to the really nitty-gritty when it comes to geometry. So let me put a little bit in perspective for you. You know, when you're younger, you first start out as a little bitty baby and you go ahead and you roll around everywhere, because before we can get to the end product of what you are today, these living human beings that can walk and talk, you have to start out as an itty-bitty little baby and learn some things as we go. So this is you as an itty-bitty little baby, and you first learn to roll. And then from there, you are a crawler. So before we can even walk, we have to crawl. And you can be just like this baby where you're so excited that you can finally do something. And it's always a great accomplishment. And then from there, you are kind of getting ready to walk. You're almost there. You need a little bit of guidance. That's me or Mr. Hatfield or Mr. Hacker. All of us are there to assist you in getting to this point here, to the final point here, where you are a walker and you can do it all by yourself and, you know, hands-free, parent-free. So our goal here is to take you from our little bit of Tootsie Roll here, and you can just do a little bit of geometry, to be a full-fledged geometry person, and you can do everything that we have ever asked you to do, and so that you can feel like this little baby. Yes! Who's excited? I hope you are excited. Please make sure as we go. However, some of you might be listening to this video right now, and you're going, what? What on earth is this crazy lady talking about? Well, let's take a look. Let's try something here, okay? I want you to take a look at the pictures below, okay? We want to have a short description on what an orc is. So why don't you go ahead and take a look at those pictures on the left, hit the pause button, and why don't you write a short description of what it might be. Okay, so taking a look at these here, some of you might recognize where these are from. Okay, what I'm noticing about orcs is that they all have green or gray skin. So that's what's in common between those pictures that I'm seeing there on the left. And they also have those underbites, and they are very muscular. So they're probably doing a lot of working out there. So underbites, muscular, and they are green. So the reason we do that is because we need some really good definitions. They are kind of like the basis of what we do everything off of. If I describe something to you, I need you to be able to identify it later. So for example, in here, I want to know out of those four on the right, which one would be considered an orc. So I'm going to go through every single one of these and identify, do they have those same characteristics? So out of all these, which one has the gray or green skin, but also has the underbites? So taking a look at the C and D, for example, now the letter C there, that is a man. He's clearly not an orc. His skin is the same color as some human beings. And the one on the bottom right there, he doesn't have an underbite. He doesn't have gray skin or anything like that. But we look at the top two. Okay, we got some gray or green skins going on. So now we want to look at the underbite. And as you can see, the one on the top left there, that guy is our orc, as he has that underbite. It kind of looks very similar to the ones that are there. So why did we do that? Again, like I said, our focus here is getting some really good definitions to base everything off of. So let's start getting to the nuts and bolts of our geometry class and being able to reference things. So these are going back to our basics, starting out with what a point is. So again, please make sure that you are taking notes, especially when it comes to definitions, any theorems, any formulas. You want to write those down. So definitions, our first definition is what a point is. You've used points in the past, I'm sure, with your algebra class. It has location and nothing else. There's no size to it, there's no height to it, there's no depth to it. This is our most basic unit of geometry. And when I identify these, we always use a capital letter. For example, here, this point here, now while it seems like there's depth to it, it looks like a circle, it actually is not a circle. It just represents a location, which is why on a coordinate plane, we usually use the x and the y values, or 2, 3, or -1, 0, the coordinates to identify its location. So as you can see here, I have that letter A, and it is a capital. So when I ever ask to name it, I would say something like point A. Okay. Now, when we take a bunch of points and put them together, that's when we form a line. So a line is a straight, unbroken set of points that goes on forever. It has infinite length, but no thickness. Okay, so even though that the point only has location and there's no size to it, when we put a whole bunch of them together, that's when we form ourselves a line. Now, when we draw a line, we typically use at least 2 letters representing at least 2 of the points. Now there are infinite number of points on here, and as you can see there are arrows at the end of that line, and that's very important. That's what makes it a line opposed to something else that we'll see in the very near future. So with this we're using 2 letters, A and B. Obviously those can change. So here's a couple ways that we can name it. So using the letters that are on there, we have A, B. Now what I want you to really note is the notation that's on there. As you can see, we have the A and the B there. But what is going on above it is kind of what I want you to notice. Above the letters, the symbols look exactly like a line. And it's really important that we have the letters, the arrows at the very top there that are going on. So let me grab my pen here so I can kind of point that out to you a little bit better. And what I'm talking about are these arrows here and here. We're matching the fact that these have arrows here. So if ever I'm representing a line, then I want to make sure that we're using those lines. That notation is very important. We can also use the lowercase, one single letter. We can't use the points A, B, or BA, whichever one you want to do. But we can also have on the screen, let me get back to my... Sorry. We can also have something like the letter H. What is going on? Sorry about that. We can also have the letter H sitting right there. So we can name it using that letter. That does not have a point next to it. So as you see, it's out by itself. Usually it's lowercase and it is usually in script. Like I can use the letter L or can use the letter S, things like that. And then we can name it line H. So there's 2 ways, well really 3 if you think about being back and forth between each other like A, B, B, A. We have the first way would be using the correct notation up top here, and the second way would be using that lowercase letter. Okay, so kind of thinking about these things, our most famous question that's always asked of us is, when are we going to use this in real life? So I would like to give you some examples of these things in real life. So let's start off with the points. So kind of thinking about things, even though again we realize that there's no size to it, we're going to go off of the physical model. If we take a look at one of these lovely blue, they're poppy seed bagels. One of those little guys, that is what we can call a point. So there we go. We have one of those points in real life. Another example, taking a look at these, taking a look at what is formed, these guys here, we'll call those lines. Okay, so just kind of giving you that idea of what would that look like in real life. Now I realize that in real life, lines will not continue on forever and ever and ever on these specific electrical things here, and they will stop. But for the sake of the example here, we'll work with that. All right, moving on to our next set of definitions. So our next one here is what a plane is. So a point had no depth, a line had no thickness, a plane, it's a surface and it has length and width, but again there is no thickness to it. Once we start getting thickness to it, that means we're getting into our 3-dimensional shape. So we're talking about stuff that's just sitting down on a plane. So it is a flat surface that is going to extend forever. And there's a lot that I want you to be paying attention about with this. Okay, so now taking a look at the letters on there, I have the letters A, B, and C, and I have the letter M. So what I want you to note though is that A, B, and C, they all have these little points here. Okay, so when we name these, there's 2 ways that we can do it. The first way is always going to be through 3 non-collinear points. And I'm going to go over what collinear means a little bit later. But for right now, the first way would be using the 3 letters that are sitting on the plane. So A, B, and C. The second one is going to be kind of like what we did with the line, in the sense of there was a letter that was by itself. In this case, it's the letter M. So for this, it's going to be the second way to name a plane. So first is using 3 points, and we'll talk about what non-collinear means in a moment. And the other way is through the one that doesn't have any points by itself. So now I was saying before is that line segment, or a line continues on forever. The second we have is a line segment. And a line segment has 2 endpoints. So as you can see here, we have ourselves a line segment. There are no arrows at the end. It's very important to take note of that. So if I were to name this one, the notation is going to look a little bit different. See how that notation uses a line segment and has no arrows in the end. Once we include an arrow here, that means we're talking about a line. So that notation is very important. There's a difference between a right and a wrong answer. So please make sure you're keeping track of that, okay? So as you can see, we can name it AB, or we can do the reverse using BA. If there's a third letter in here, say C, we can call it ABC. What matters is that this point and this one on the end here, we are using the endpoints, okay? Because that's telling us the location of the beginning and the end of that line. The next thing we have is array. That's a line that only contains one endpoint. So kind of putting the line and a line segment mushed together. Okay, so this is what an array would look like. As you can see, we only have one endpoint. These two pieces, y and b, are non-endpoints because there's a line that's going to continue right through that. So now when we name this, it's very important. The first letter always tells us where we're starting. So it's always the endpoint that's going to go first. In this case, it's the A. The second letter that's used is always going to be the direction. So in this case, Y or B is telling us what direction our array is going in. So if we had another point over here, say we had point D somewhere up here, then that would be telling me that our array is going that way. So you have to make sure you're naming it correctly. Again, endpoint first, and then going on from there. Again, take a look at our endpoint. Our notation here. This is array because it looks exactly like array. We try to keep it pretty simple like that in geometry. If we have a reference to opposite rays, these are rays that are sharing a common endpoint and extend in opposite directions. And what you're going to see is it essentially looks like a straight line. So if the endpoint, common endpoint here is A, rays AB and AC are going to be our two opposite rays, with one going in this direction and the other one going in this direction, so forming that straight line. Okay? Continue on with looking at some real models in real life. Okay? For those of you who like this kind of stuff, we have the laser pointing out. Now, technically, lasers will go on forever and ever and ever, unlike the lightsabers that you find in your Star Wars, for you Star Wars fanatics. But lasers do continue on forever and ever. Just even though the planes do continue on forever and ever as well, since we can't draw lines that represent that or planes that represent that, we're going to use this little flat surface here of dough. Okay, let's continue on. We want to kind of think of the prefix co, and I mentioned collinear before. Things like co-worker, people who work together, cohabitat, people who live together. So if I were to say something like collinear, kind of thinking about that co and what linear means, what that means is we're having something that's on the same line. Okay, so for example, points F, Z, and P are collinear. So now going back to that plane idea, those things cannot be collinear. Coplanar, okay, that means the same idea, but now it's on the same plane. So kind of use a little bit of your brain there and think co means the same, linear means that line, planar means a plane. So again, going back to naming a plane, A, B, and C here, they do not form a straight line, so they are non-collinear, and that's what you do to name or use to name it. Okay. For our very last definition here, thank you for sticking in here with me, we got our angle. That's two rays that share a common endpoint, provided the two rays do not lie on the same line. So they're not going to be forming a straight line. That common endpoint is known as the vertex. Okay, so here's a visual of that. This point right here, that is our vertex. And as you can see, the two rays, ED and EF, are going off in different directions. Couple ways to name this. First way would be using angle DEF. Again, look right here at that notation. It looks exactly like an angle, and we're going to do the exact same thing. Or we could do the reverse, FED, or lastly, we can use angle E. I want you to notice what's in common here is the vertex is found exactly in the middle here and here, and we can name it by the vertex. However, one thing that's contingent with that. If we had another line drawn out of this vertex, such as this, and let's call that G, I cannot name that angle by just the vertex because that technically references this angle, and the main angle there. So that is very important for you to understand. Okay, and as always, we like to take a look at things of physical models in the real life. So for angles, I'm sure you can come up with plenty more. But this would be another example of that, okay? This is very, very old school. Most of you probably have never seen one of these things, but these are our rabbit ears. So hopefully you are getting a good idea on these basic definitions, and this is not you right now. This is Mr. Hatfield when he was a little baby. Hopefully this is not you right now, and instead we are feeling accomplished. We have the beginnings of geometry. I hope you have enjoyed your very first video. I look forward to seeing what your notes look like. Please make sure you ask any questions if you have any.